All right, so I'm just going to walk you through this particular question here that I've made up. If you have a 25 kilowatt load hooked up to a 280 volt single phase source using RW90 600 volt non-jacketed copper conductors, what would your minimum breaker size be? What is your minimum conductor size? What is the minimum bond wire size? And what is the minimum rigid PVC conduit size? So let's go through this systematically. So first thing we got to do is figure out the actual draw of amperage that this particular load is going to have. So we got 25 kilowatts at 208 volts. So we're going to take our 25,000 watts divided by 208, and using Watt's law, we can figure out what the current is going to be. So 25,000 divided by 208 is equal to 120.19 amps. Alright, so the slightly extra current that we're getting over 120 is really important here, so we can't leave that out. So the first thing I need to be aware of is that a typical breaker, unless stated otherwise, is only good for a continuous load up to 80%. So we're going to assume, and we're always going to assume, that the load is going to be continuous unless stated otherwise. And we're always going to assume that the breaker is going to be rated for only 80% unless stated otherwise, because that is absolutely the norm. So we can't take this 120.19 amps at face value. We need to be able to figure out what the current draw is going to be. We're going to have to figure out what the breaker or actual ampacity is going to be that would result in 120.19 being 80%. So we're going to divide that by 0.8, which is going to give us 150.24 amps. So again, this 0.24 is really important, and you'll see that in a moment. All right, now that we have our 150.24 amps, we need to find a conductor size that is copper, that is copper, that is going to meet the requirements of that 150.24. So let's take a look at our code, table 2, which is going to be copper conductors. And now we have to go from the 75-degree column again, because when we go back to our question here, our breakers are typically rated at 75 degrees Celsius. So we're not going to have the ability to use our 90-degree column, because that conductor ultimately terminates on an electrical device only rated for 75 degrees. So we have to remain in that 75-degree column. And again, the question's going to, you're going to assume it's 75 degrees unless stated otherwise also. So now we got to find a particular conductor here that is rated for something slightly over 150.29. So you'll see here, single aught is close, it's 150, but it's not going to meet our requirements. We need to upgrade to 2-aught here, which is good for 175. All right. So I'm going to write that in here, 2-aught, and I'm going to write in its ampacity value, which is going to be important, of 175 amps. Okay, so the next thing I'm going to do is go back to my code book, and under table 13, we're going to be able to distinguish our overcurrent device size, so our breaker size. And if we scroll over to the third column, we're going to find something that is going to meet the needs of our 175 ampacity. So again, we're not focused on the load draw, we're focused on the ampacity of the actual conductor, and it's going to be 151 to 175, so we're able to put a 175 amp breaker on there. So I'll fill that in here. Now remember that the breaker has to be it can't have more than 80% of its total value taken up by the load. So let's see what 80%, just for fun here, of 0.71 of 175 is. So 175 divided by 175 times 0.8 is 140. So 140 amps is more than enough to be capable of handling our 120.19 continuous load. Now let's just, for example, take 150 amps and just see what 80% of that is. So if we take 150 amps and multiply it by 0.8, we end up with 120 amps. And you'll notice here that 120 amps, though slightly under, barely, is still not going to meet the requirements of that 80% rule for our load. And so 150 amp breaker would not do, it would not suffice, which is why we have to go to this 175 amps. Okay. So next we can go to our bond. That's going to be found in table 16. And again, it relates back to our ampacity of the 2-aught conductor. So let's turn there. And we're looking, in this case, it's attached to a breaker, 175 amp breaker. And so we got to go to something that exceeds that 175. So we're going to go to 200, and we can see that we can put a number 6 on there. So according to table 16, a number 6 copper conductor will suffice for a bond if it's attached to a 175 amp breaker. Okay, next we're gonna use table 6, 8, and 9 to figure out our conduit size. Alright, so first we're gonna go to table 6. And we're gonna go to 6A because 6A deals with R90 and it's 600 volts. Alright, so if we cross-reference here to 2-aught, we'll see that number 2-aughts are good for 284 milliamps. So let me write that in here. Our 2-aught conductors equals 284 millimeters squared. Now, keep in mind, just going back up to the question here, that we are hooking up to a 208 volt load. And so the 208, because it doesn't have 120 in it, this is going to be a non-neutral type load. So think about our baseboard heat in our suites that we're mocking up. Those go to a 240 volt breaker, but there is no neutral. So we only, in our conduit, we're going to need room for 2 hots. And that's it, plus our bond. So 3 wires total. So we got to keep that in mind. All right, so now that we figured out the area that our 2 hot conductors are going to take up, we need to figure out what our number 6 bond is going to take up. So let's go back to our table 6A. We'll cross-reference number 6, and already highlighted there for us, one number 6 is going to take up an area of 38 millimeters. Not much at all. Okay, 38 millimeters squared, I should say. Okay, so now we got to add those 2 conductors up. 284 plus 38 equals 322 millimeters squared. All right, and now we got to, well, let's take a look at table 8 here. Table 8, what that's going to say is if we have more than 3 conductors in there, then we're going to take it at 40%, which we do. and they're all insulated. And I guess I should state here that we're going to assume that the copper bond wire is also insulated with RW90 XLPE. That should be stated in the question a little better. But in this case, we're going to assume so. Okay. So now I'm going to go to table 9. I'm going to go to table 9G, and I'm looking for rigid PVC, which is in this third column here. And I'm looking for enough area to meet the needs of my 300, and what did I say it was? 322 millimeters squared. And so 35 is just going to be shy of what I need to meet that 40% requirement. And so I got to upgrade to trade size 41. So that's going to be the answer to my conduit. So TD 41. Now, just for fun, I might ask you in the exam, what is trade size 41 in standard measurement? What is it in inches? So again, if we go to our code book and we go to the very beginning of it on page, I think it's 34. Here it's labeled conduit tubing and fitting sizes. If we take a look at our metric designator 41 here, trade size 41, it's going to equate to 1.5 inches conduit size. And so I'll make note of that as well. Okay, I hope that helps.